Hello everyone. In this video, I will be talking about continuity at a point. If a function is continuous at a point, then it means the function is going nicely through. Function is very smooth and uninterrupted. What does uninterrupted means? It means there is no hole, no break, gap, or no jump. If we have one of these situations, that function is discontinuous. Otherwise, if none of them is in the graph, none of them is in the function, then it is a continuous function. So in below, we have some situations involving this continuity. Let's review them one by one. The first one, I see a gap here. I see a hole. So it is considered to be a discontinuous function. So in such situations, function is not defined because there is a gap, there is a hole. Another situation involving discontinuity is having jump. If there is a jump, then limit does not exist. If limit does not exist, function is discontinuous. And finally, limit may exist, function may be defined at that point, but their values are not the same, so the function is discontinuous. So these are the situations involving discontinuity. So, to understand whether a graph or function is continuous or not, we should check whether we can draw the graph without lifting our hand. For example, the first one. When I start drawing the graph, I should pick up my pencil here to continue drawing the graph. So there is an interruption here. There is a disconnection. So it is discontinuous. Similarly, sketch your graph until here. To continue sketching, I should move down. I should jump down and continue. So I should pick up my pencil to continue drawing. So it is not considered to be a continuous function. And finally, when I come here, there is a hole. I should stop, jump down, and jump up again and continue drawing. So there is a disconnection. I cannot say this is continuous. So all these three conditions are conditions of discontinuity. Okay, they are all discontinuous functions. So we can say a function to be continuous at a point, a whole bunch of things should happen. The first thing that has to happen is function to be defined at a point. Otherwise, there is a hole, just like in the first graph. The second thing that has to happen is limit has to exist. Otherwise, there is a jump, there is a discontinuity, there is a disconnection. And finally, limit, even when the two-sided limit exists, but the limit is different value than the value of the function, that will also not be continuous, just like the last example. Limit exists, function is defined, but their values are different, so there is still a disconnection. So whenever there is disconnection, interruption, a hole, a gap, or a break, then the function is considered to be discontinuous. Okay, this is how you identify discontinuity from the graphs. Let's take a look at an example. Find values of x where the function is not continuous. So when I start graphing, I start from the left, I graph until at 1. When I come 1, the graph is broken. I should jump up to continue drawing. So there is an interruption here. I cannot draw my graph without lifting my hand, without lifting my pencil. So at that point, there is a jump, this connection. So 1 is point of discontinuity. Okay, let's move on. Continue graphing. When you come here, you go infinitely. There is no way that I could draw from here to here without picking up my pencil. It's going forever. So this part and that part is not connected. So there is a break. So at that point, we have point of discontinuity. What is that point? That point is 2. And continue graphing. I come till here, and there is also a gap. There is also a hole. So I should lift my pencil to continue drawing. So at that point also we have discontinuity. So we totally have 3 points that function is discontinuous here. Here is the first point, x equals 1, there is a jump, so limit does not exist. At x equals 2, there is a break, limit does not exist. At x equals 3, there is a hole, limit exists. Function is defined, but their values are different from each other. So here are the situations that function is discontinuous. So that graph is discontinuous at those 3 points only. Everywhere else, function is discontinuous. Just those 3 points are the points where function is discontinuous. Okay, just because we have discontinuity at these 3 points doesn't mean that the whole function is discontinuous everywhere. It just means there is discontinuity at those 3 points only. Okay, points of discontinuities are only 1, 2, and 3. Everywhere else function is continuous. All right. So these are the situations where we can see discontinuity. This is how we identify discontinuities from the graphs.